Hey everyone, welcome back to the channel. I'm Darshan, and today we are diving deep into one of the most critical decisions you will make in Rust backend development. Which ORM should you use in 2026? If you have been building Rust applications that need database access, you have probably faced this dilemma. Diesel, SQLx, SeaORM, Rusqlite. They are all popular, they all have passionate communities, and everyone has a different opinion on which one is the best. Here is the reality. There is no single best ORM. Each one has its philosophy, its strengths, and its ideal use cases. Today, I am giving you the complete breakdown. Real talk, no hype, just practical guidance so you can pick the right database layer for your project. So why should you care about Rust ORMs in 2026? 3 reasons. First, type safety. Rust ORMs leverage the compiler to catch database errors before runtime. Invalid queries, caught at compile time. Type mismatches, caught at compile time. Type mismatches, caught at compile time. Schema mismatches, caught at compile time. You are not finding SQL errors in production at 3 a.m. Second, async support. In 2026, async is the standard for Rust backends. All 4 ORMs we are covering today have mature async support, though they approach it differently. This matters for performance and scalability. Third, the ecosystem has evolved significantly. SeaORM just hit version 2.0 with major improvements. Diesel continues to be the reliable choice with version 2.3.6. SQLx at 0.8.6 offers unique compile time checking. And Rusqlite 0.38.0 remains the go-to for SQLite. If you are serious about Rust backend development, understanding these ORMs is essential. Here is exactly what you are getting in this video. I will introduce each ORM with its philosophy and approach. I will cover the key features that make each one unique. I will show you the latest versions and what is new in 2026. I will explain when to use which ORM. And at the end, I will give you my honest recommendations for different scenarios. Whether you are building a web API, a CLI tool, a data processing pipeline, or a desktop application, by the end of this video, you will know exactly which ORM to choose. Before we dive in, subscribe if you have not already. I am posting Rust content every week, and the Rust community here is growing fast. Hit the notification bell so you do not miss the next one. Also, join our Discord. Link in the description. That is where we discuss code, debug issues together, and share projects. The community there is incredible, and if this video helps you pick the right ORM, consider buying me a coffee. Every coffee funds more tutorials like this. Link is below. Alright. But before we get into the ORMs, let me quickly explain what an ORM actually is, because context matters. So, what exactly is an ORM, and why do we need one in Rust? ORM stands for Object Relational Mapping. It is a layer that sits between your application code and your database. Instead of writing raw SQL strings, you work with Rust structs and methods. The ORM translates your Rust code into SQL queries. Without an ORM, you would write SQL queries as strings, manually bind parameters, and map results to structs. It is tedious and error-prone. With an ORM, you write Rust code that looks like this. You call methods on structs, and the ORM handles the SQL generation, parameter binding, result mapping, and type conversions. Less boilerplate, more safety, and often better performance through query optimization. Rust ORMs fall into roughly 3 categories. First, full-featured ORMs like Diesel and SeaORM. These provide query builders, migrations, schema management, relationships, and the full kitchen sink. They aim to handle every database interaction need. Second, query builders with compile time checking like SQLx. SQLx is technically not an ORM. It is a SQL toolkit. But it provides compile time verified queries without a domain-specific language. You write SQL, SQLx checks it at compile time. Third, lightweight drivers like Rusqlite. These are thin wrappers around database drivers. They do not provide high-level abstractions, but they give you maximum control and minimal overhead. Each approach has trade-offs. Full ORMs give you convenience but add complexity. Query builders give you safety without the ORM overhead. Lightweight drivers give you control but require more code. Today we are comparing the top 4 Rust database libraries as of February 2026. Diesel version 2.3.6, released January 2026. The mature, compile-time checked ORM. SQLx version 0.8.6, the current stable release. The Async SQL Toolkit with Compile Time Verification. SeaORM version 2.0, released January 2026. The Async First, Dynamic ORM. And Rusqlite version 0.38.0, released December 2025. The Ergonomic SQLite wrapper. Let us dive in, starting with Diesel. ORM number 1 is Diesel. If you ask me to recommend one ORM as the default choice for most Rust projects in 2026, especially if you are working with PostgreSQL, mysql, or SQLite, this is it. Diesel is the most mature ORM in the Rust ecosystem. It has been around since 2015, which is ancient in Rust years. It is battle-tested in production at companies like GitHub, Mozilla, and countless others. The philosophy of Diesel is type-safe SQL. Everything is checked at compile time. If your code compiles, your queries are valid. This is not marketing speak. It is literally true. Diesel uses Rust's type system to verify your SQL at compile time. Version 2.3.6 just dropped in January 2026, and it continues the tradition of stability and reliability. Let me tell you what makes Diesel special. First, compile time SQL verification. This is Diesel's superpower. When you write a Diesel query, the SQL is generated and checked at compile time. If a column does not exist, if a type does not match, if a table is misspelled, you get a compile error, not a runtime error. The way this works is elegant. Diesel generates Rust code from your database schema using a command line tool called dieseltl. This generated code includes the types for your tables, columns, and relationships. When you write queries, you are working with these types. The Rust compiler verifies that your queries are valid against the schema. Second, zero-cost abstractions. Diesel queries compile down to SQL that is as efficient as handwritten SQL. There is no runtime overhead for the ORM layer. The query builder generates optimal SQL. Third, migration system. Diesel has a built-in migration system that has been refined over years. You create migration files, Diesel applies them in order, and it tracks which migrations have been run. schema versioning is handled automatically. Fourth, connection pooling. Diesel integrates with R2D2 for connection pooling out of the box. Production-ready connection management is one import away. How does Diesel perform? Diesel is fast, the generated SQL is optimal, the compile time checking means no runtime surprises, memory usage is predictable and minimal. More importantly, Diesel is safe. The type system prevents SQL injection. Queries are parameterized automatically. The ownership system prevents use after free and data races. schema mismatches are caught at compile time, not in production. The compile time checking adds to build times, but the resulting binary is fast and safe. You are trading compile time for runtime safety, which is the Rust philosophy. What is it like to actually use Diesel day to day? The learning curve is real. Diesel requires you to understand its type system, its query DSL, and its schema management. The error messages can be verbose. When you mess up, the compiler tells you exactly what is wrong, but it might take 50 lines to do so. That said, once you understand Diesel, you can move fast. The documentation is excellent. The patterns are consistent. The community is large and helpful. Diesel works best when your schema is relatively stable. Because it generates code from your schema, frequent schema changes require regenerating the schema code. This is easy with migrations, but it is something to be aware of. So when should you use Diesel? Use Diesel when you want compile time SQL verification. Use it when type safety is your top priority. Use it for PostgreSQL, MySQL, or SQLite projects. Use it when your schema is relatively stable. Use it as your default choice unless you have specific reasons to choose something else. Diesel is my go-to recommendation for most Rust database projects. It is the safest bet. But Diesel is not perfect. Let me be honest about the limitations. First, async support is through separate crates. Diesel itself is synchronous. For async, you use Diesel Async, which provides async variants. This works well, but it is an extra dependency and adds some complexity. Second, compile times. Diesel's compile time checking adds to build times, checking adds to build times, especially for complex queries. CI builds can be slower. Third, the query DSL has a learning curve. It is not SQL. You are learning Diesel's specific API for building queries. It is powerful, but it is different from raw SQL. Fourth, for very dynamic queries where the structure changes at runtime, Diesel can be cumbersome. It is designed for static query structures. Installing Diesel is straightforward. You add the Diesel crate to your dependencies with features for your database, like Postgres and R2D2 for connection pooling. For async support, you also add Diesel Async. You will also need the Diesel CLI tool for migrations. You install it with cargo install Diesel CI. The official documentation at diesel.rs has excellent getting started guides. To summarize Diesel, it is the mature, type-safe ORM that should be your default choice in 2026. Compile time SQL verification, zero-cost abstractions, excellent migrations. If you are starting a new Rust database project and do not have strong reasons to use something else, start here. Alright. ORM number 2. ORM number 2 is SQLx. But I need to clarify something. SQLx is technically not an ORM. It is an async SQL toolkit. However, it provides compile-time checked queries, and many developers use it as an alternative to ORMs. So we are including it. SQLx's philosophy is different from Diesel. Instead of providing a query DSL, SQLx lets you write raw SQL. But here is the magic. It checks that SQL at compile time against your actual database. The way this works is brilliant. SQLx connects to your database at compile time, validates your queries against the actual schema, and generates Rust code from the result types. If your query is invalid, you get a compile error with the SQL error message. Version 0.8.6 is the current stable release, and it is excellent. What makes SQLx special? First, compile time checked raw SQL. This is SQLx's unique feature. You write actual SQL queries, and SQLx validates them at compile time. No guessing. No runtime errors from typos. Your SQL is checked against the real database schema. Here's what it looks like. You use the query as macro, pass in your struct type and your SQL query with parameters. SQLx checks that SQL at compile time. If the columns do not match your struct, if the types are wrong, if the table does not exist, you get a compile error. Second, async first design. SQLx was built for async from the ground up. It works seamlessly with Tokio and async staff-t. No separate async crate needed. Third, runtime query builder. SQLx includes a query builder for constructing dynamic queries at runtime. This is useful for queries where the structure changes based on user input, like complex search interfaces. Fourth, connection pooling and migrations. SQLx has built-in connection pooling. For migrations, you typically use SQLxti, which provides migration management. How does SQLx perform? SQLx is fast. Your queries are just SQL. There is no abstraction overhead. The compile time checking happens at build time, not runtime. SQLx is safe. Like Diesel, it prevents SQL injection through parameterization. The compile time checking catches schema mismatches before deployment. One performance consideration. SQLx requires a database connection at compile time for query checking. This means your build environment needs database access. For CI/CD, you need to set up a database or use the offline mode with prepared query metadata. What is the developer experience like? SQLx has a gentler learning curve than Diesel if you already know SQL. You are writing SQL, not learning a new DSL. If you are comfortable with SQL, you will be productive quickly. The error messages are excellent because they are actual database error messages. When SQLx fails at compile time, it shows you exactly what the database said was wrong. The dynamic query builder is well designed. For complex search interfaces or dynamic filters, the query builder is more ergonomic than Diesel's approach. One downside, managing the compile time database connection can be annoying. You need a running database during development and in CI. The offline mode helps, but it is an extra setup step. When should you use SQLx? Use SQLx when you want compile time checking but prefer writing raw SQL. Use it when you need dynamic queries with the query builder. Use it when you want a simpler learning curve and already know SQL well. Use it for projects where you want maximum control over your SQL. SQLx is excellent for teams that are SQL first and want Rust safety guarantees. The limitations? First, the compile time database requirement. You need a database running during compilation. This complicates CI/CD and requires setup for new developers. Second, no high-level ORM features. SQLx does not provide relationship handling, eager loading, or the conveniences of a full ORM. You write more code for complex data loading. Third, the offline mode workflow. While offline mode lets you build without a database, it requires generating query metadata files and keeping them in sync. It is an extra step in your workflow. To install, add the SQLx crate to your cargo.toml with features for your runtime like Runtime Tokyo and your database like Postgres. Install the CLI for migrations with cargo. Install SQLx TICI. The GitHub repository at launchbadge/SQLx-CICI. The GitHub repository at launchbadge/SQLx has extensive examples and documentation. To summarize SQLx, it is the async SQL toolkit that checks your raw SQL at compile time. Write SQL, get Rust safety. Great for SQL first developers who want type safety without an ORM abstraction. On to ORM number 3. ORM number 3 is SeaORM, and this is the one that has evolved dramatically. SeaORM 2.0 just released in January 2026, and it is a major milestone. SeaORM is the async first, dynamic ORM for Rust. Unlike Diesel's compile time approach, SeaORM does most of its work at runtime. This gives it flexibility that Diesel cannot match, though it trades some compile time safety for that flexibility. SeaORM is built on top of SQLx, which means you get SQLx's async foundation with SeaORM's high-level ORM features on top. The philosophy of SeaORM is productive async ORM. It aims to provide the ergonomics of ORMs like Django ORM or Active Record, but for Rust. What makes SeaORM special? First, fully async. Every operation is async, no separate async crate needed. It works seamlessly with Tokyo. Second, runtime flexibility. Because SeaORM builds queries at runtime, you can construct dynamic queries easily. Complex search interfaces, optional filters, dynamic sorting, all straightforward in SeaORM. Third, entity generation. SeaORM can generate Rust entities from your database schema. Unlike Diesel's compile-time code generation, this happens through a CLI tool. The generated entities include active model patterns for inserts and updates. Fourth, relationship handling. SeaORM has excellent support for relationships. One-to-many, many-to-many, eager loading, lazy loading. The API feels like modern ORMs from other languages. Fifth, SeaORM 2.0 features. The 2.0 release includes Entity Loader for efficient batch loading, Nested Active Model for complex inserts, and an entity-first workflow. It also introduced SeaORM Sync, a synchronous variant for CLI tools and SQLite applications. How does SeaORM perform? SeaORM is performant, though there is some runtime overhead from the dynamic query building. For most applications, this overhead is negligible. SeaORM 2.0 improved performance significantly. The entity loader reduces N+1 query problems. The query builder generates efficient SQL. Safety is different from Diesel or SQLx. SeaORM does not catch SQL errors at compile time. Instead, it returns results that you must handle. Runtime errors are possible, but the type system still prevents many classes of bugs. SQL injection is prevented through parameterization, just like Diesel and SQLx. What is it like to use SeaORM day to day? The learning curve is gentle if you have used ORMs in other languages. The patterns are familiar. Entities, repositories, migrations. If you have used Django ORM or Active Record, SeaORM will feel natural. The documentation is excellent and improving rapidly. SeaORM 2.0 stabilized the API, so the documentation is more reliable than in earlier versions. The dynamic nature means faster iteration. You can change your schema and immediately work with it without regenerating code or waiting for compilation. This is great for rapid development. When should you use SeaORM? Use SeaORM when you want a modern, async-first ORM. Use it when you need dynamic queries without fighting the type system. Use it when you are building web APIs and want relationship handling. Use it when you prefer runtime flexibility over compile time checking. SeaORM 2.0 is production-ready and a great choice for new projects in 2026. The limitations? First, runtime errors are possible. Unlike Diesel or SQLx, schema mismatches are caught at runtime, not compile time. You need good test coverage. Second, it is newer than Diesel. While SeaORM 2.0 is stable, it has not been around as long. The ecosystem of plugins and extensions is smaller. Third, the runtime overhead. While minimal, there is some overhead from dynamic query building. For extreme performance requirements, Diesel or SQLx might be better. To install SeaORM 2.0, add the SeaORM crate to your dependencies with features for your database driver and async runtime. Install the CLI for entity generation and migrations with cargo. Install SeaORM CI. The documentation at seorm.org is comprehensive. To summarize SeaORM, it is the modern, async-first ORM with excellent flexibility. SeaORM 2.0 brings major improvements. Great for dynamic queries, relationship handling, and rapid development. The future of Rust ORMs. Framework number 4. ORM number 4 is Rusqlite. But calling it an ORM is generous. It is really a lightweight wrapper around SQLite. And that is exactly its strength. Rusqlite provides ergonomic bindings to SQLite for Rust. It is not trying to be a full-featured ORM. It is giving you direct access to SQLite with Rust's type safety and ergonomics. Version 0.38.0 was released in December 2025, with support for SQLite 3.51.1. It is actively maintained and reliable. If your project uses SQLite, and many Rust projects do, especially CLI tools, desktop apps, and embedded systems, Rusqlite is the standard choice. What makes Rusqlite special? First, SQLite focus. Rusqlite is purpose-built for SQLite. It provides access to SQLite-specific features that general-purpose ORMs do not expose, custom functions, virtual tables, extensions, and more. Second, bundled SQLite. The bundled feature compiles and links SQLite automatically. You do not need SQLite installed on the system. This makes deployment incredibly easy. Your binary includes everything it needs. Third, zero-cost abstraction. Rusqlite is a thin wrapper. There is minimal overhead over raw SQLite C calls. Performance is excellent. Fourth, connection and transaction management. Rusqlite provides ergonomic APIs for connections, prepared statements, and transactions. The borrow checker ensures you do not misuse resources. Fifth, feature flags. Rusqlite has extensive feature flags for different SQLite extensions. JSON support, full-text search, backups, blobs, and more. You only pay for what you use. How does Rusqlite perform? Rusqlite is fast. It is a thin wrapper around SQLite, which is one of the fastest embedded databases available. The performance is limited by SQLite itself, not Rusqlite. Memory usage is minimal. SQLite is designed for embedded use, and Rusqlite maintains that philosophy. Safety comes from Rust's type system and ownership model. The borrow checker prevents use after free and data races. Prepared statements prevent SQL injection. One note, Rusqlite is synchronous. For async SQLite, you typically use SQLx or run Rusqlite in a blocking thread pool. What is the developer experience like? Rusqlite is straightforward. If you know SQLite, you know Rusqlite. The API maps closely to SQLite's C API, but with Rust ergonomics. The documentation is solid, the examples are clear. The error messages are helpful. For simple SQLite projects, Rusqlite is perfect. For complex database needs like relationships, migrations, or query builders, you will need to build those yourself or use a different library. When should you use Rusqlite? Use Rusqlite when you are using SQLite. Use it for CLI tools, desktop applications, embedded systems, and anywhere you need a file-based database. Use it when you want minimal dependencies and easy deployment. Use it when you need SQLite-specific features. If your project uses SQLite, Rusqlite is the obvious choice. The limitations? First, SQLite only. Rusqlite does not support PostgreSQL or MySQL. It is SQLite or nothing. Second, no high-level features, no ORM conveniences, no query builder, no relationship handling. You write SQL and map results manually. Third, synchronous only. If you need async SQLite, look at SQLite's SQLite support or use a thread pool. To install Rusqlite, add the Rusqlite crate to your dependencies with the bundled feature enabled. This compiles SQLite for you automatically. The GitHub repository has excellent examples. To summarize Rusqlite, it is the ergonomic SQLite wrapper. Thin abstraction, maximum control, easy deployment with bundled SQLite. If you are using SQLite in Rust, this is your library. Alright, let us bring it all together. Here's how these 4 libraries compare. Diesel. Compile time SQL verification, mature, zero-cost abstractions, version 2.3.6 as of January 2026. Best for type safety and stable schemas. SQLx. Compile time checked raw SQL, async first, query builder. Version 0.8.6. Best for SQL first developers who want safety. SeaORM. Async first, dynamic, relationship handling. Version 2.0 released January 2026. Best for rapid development and web APIs. Rusqlite. SQLite only, lightweight, bundle deployment. Version 0.38.0. Best for SQLite projects. Let me give you a simple decision flow chart. Are you using SQLite? Use Rusqlite. Do you want compile time SQL checking with a query DSL? Use Diesel. Do you want compile time checking but prefer writing raw SQL? Use SQLx. Do you want a modern async ORM with dynamic queries? Use SeaORM. Do you need dynamic search interfaces or complex filters? Use SeaORM or SQLx. Is your schema stable and type safety critical? Use Diesel or SQLx. That covers most scenarios. Here is my honest take. If I'm starting a new PostgreSQL or MySQL project with a stable schema, I reach for Diesel. The compile time checking catches so many errors, it is the safest choice. If the project needs dynamic queries, complex search, optional filters, I use SeaORM 2.0. The flexibility is worth the trade-off, and the async ergonomics are excellent. If I am working with a team that prefers SQL, I use SQLx. The compile time checking of raw SQL is unique and valuable, and if it is SQLite, I use Rusqlite. It is the standard for a reason. One final note, you can migrate between these ORMs if needed. They all work with standard SQL databases. Your schema is portable. Your SQL knowledge transfers. Start with one. If it does not work out, switching is possible, though it requires rewriting your data access layer. The concepts transfer between ORMs. The worst decision is analysis paralysis. The best decision is the one you act on. Alright, let us recap what we covered. We went through 4 major Rust database libraries: Diesel, the mature, compile time checked ORM with excellent type safety; SQLx, the async SQL toolkit with compile time verified raw SQL; SeaORM, the modern async first ORM with dynamic query capabilities and SeaORM 2.0 improvements; Rusqlite, the lightweight ergonomic SQLite wrapper. Each has its place. Now you know when to use which. Now here is what I need from you. First, drop a comment. Which ORM are you going to try first? What are you building? I read every comment, and I want to know what the community is working on. Second, subscribe to the channel. I am posting Rust content every week, tutorials, project walkthroughs, ORM deep dives. If you are serious about Rust, this is your channel. Third, join the Discord, link in the description. That is where we help each other, share code, and discuss the latest developments. Fourth, if this video helped you, buy me a coffee. Every contribution funds more content like this. Link is below. Fifth, check out my GitHub, SeaORM Dev Hub. I have got example projects using several of these ORMs. Fork them, learn from them, build on them. Thanks so much for watching. I am Darshan. Keep building, keep learning, and I will see you in the next one. Now go write some Rust. Peace.